Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. In the last couple of videos we worked on setting up an infrastructure for game code development. First, whenever we create a new game project, we also generate a Visual Studio solution for the game code. Then we made it possible to open an instance of Visual Studio from within the level editor and add source files to the solution that would contain the game code. The next step, as you might have guessed, is to build the game code, and that's the subject of today's video. Let's start by adding a button in the world editor that we can press to build the game code. Here next to this new script button, I'm going to add another button. And for now, it doesn't do anything because we don't have any logics to build the game code yet. That's what we are going to do next. But before that, I need a combo box as well so that I can choose what configuration I want to build the game code. As you can see here, now we have the combo box that we can use to choose what configuration we want to build our game code with. And there is this button that we can press, but it doesn't do anything yet. So let's write a method that we can call when we press this button. Before writing that method, though, I want to know what configuration we should use because remember we have 4 configurations: debug, debug editor, release, and release editor. But we only have 2 options here, and we can decide which one of those 4 configurations we can use depending on whether we want to build the game code as a DLL to be loaded in the level editor, or we want it to be output as a standalone executable. So for that, I'm going to add an enumeration type. Here in this file, I'm just going to add an enumeration type. And then here in project class, I'm going to have an array of strings that will give me the name of these build configurations as a string. And then I'm going to write a method that will give me one of these configuration names depending on this enumeration type. Now I can have a new property that I can use to bind to this combo box. So when I change the selection here, I can change the value of that property. Now I can use this property to bind to this combo box. So the value of this property can be either 0 or 1 because we only have two options here. So the selected index of this first item is 0 and the second item has the index 1. So the value of build config is either 0 or 1. And then from that, we can figure out which one of these four configurations we need to use, depending on whether we want a DLL or an executable. So for that, I'm going to create two new read-only properties. So if we want to make a standalone application and we have the build config on debug, so the first item is selected, then we choose build configuration debug and release otherwise. And for the DLL, we of course do the same, but then with debug editor and release editor. The next thing is to add a new command that we can use to call the build method. Here, to execute this command, we need to call a method that would build our game code DLL. So I need to implement this now. The first thing we would like to do when we are going to build a game code DLL is, of course, to unload the DLL. Because after we build our game code DLL, we load the DLL in the level editor. So we need to unload it first. And then build the game code. And if the build was successful, we can load the game code DLL again. So here we need two more methods that will load and unload the game code DLL. And to build the game code itself, we need to implement a new method in Visual Studio class. We need to tell this method what solution it's going to build for us. And that information is in the project class itself. So I'm just going to give it this as one parameter. And the other parameter is, of course, the build configuration. For that, I'm going to use this method to get the build configuration name. And then we also need to ask Visual Studio whether it succeeded building the solution. And then we, of course, have to put this in a try-catch block as well, because any of these operations could fail and throw an exception. Okay, now we can go back to world editor and bind this command to this button. And next, just implement this method and property in Visual Studio class. Before we tell Visual Studio to build the game code, we need to make sure that Visual Studio is not already running the code or doing something that is going to interfere with building the solution. So here I'm going to check if Visual Studio is not in debug mode. So here I'm going to try and ask Visual Studio if it's debugging a process. Here we check if Visual Studio instance is not null, and then if that's the case, then we can ask the debugger if it has a current program. If that's not null, that means that debugger is running a program, or the debugger current mode is running. If one of those is true, then that means that Visual Studio is debugging the game code currently, and we can't use it to build the game code. And if somehow it fails to ask for this information, it will throw an exception. And that means that probably Visual Studio is busy doing something and we need to wait for it. And here we wait for a second. And I'm going to try this 3 times again. And after that, we give up and return false. So if Visual Studio is not debugging, then we can open it in case it wasn't already opened. And then I set build succeeded to false because we are going to start building. So this should be false. And I'm also going to add another property to indicate whether a build is done. So it's actually the same Boolean, but another name. Next, I'm going to open the solution if it's not already open. And after we open the solution, we need to activate this build configuration for the solution. And finally, we can issue a command to Visual Studio to build the game code. Again, all of this can fail, so I'm going to put them in a try-catch block. And again, we are going to try this 3 times. Here, I would also like to add another parameter that we can use to tell this method to show Visual Studio window whenever we start building the game code. This is an optional parameter and its default value is true. So if we don't give this parameter while calling this function, the Visual Studio window will become visible. Further, I'd like to add event handlers for build events. So whenever our build starts and it's done, we get notified and Visual Studio will give us some information about the status of the build. when the build begins, we get notified because Visual Studio build events will call this method. And when that happens, we just send a message to the logger with this information. And when the build is done, we let the user know if it succeeded or not, and also set this build done and build succeeded accordingly. And sometimes Visual Studio will call this method multiple times, and if the build is done already, that means that we have been in this method, so we just return. Going back to the project class where we were implementing this build game code DLL, we can finish this now. Here I'll also add an optional parameter for showing the Visual Studio window. And then we can also give that here in the command parameter. And I'll also put a predicate here to enable or disable this button. So if, for example, Visual Studio is already building our project or it's running the code, that means that we can't use this command. Here in World Editor, if we want to give this command a command parameter, if we would type in true, then it would just pass a string to this command. But obviously, we expect here to have a Boolean value, and it would crash the program because a string is not a Boolean. And for that, we can create XAML resources here that represent a true Boolean or a false Boolean value. So now we can use this static resource that we created here, which represents a Boolean value. And we use this key to indicate that we need the true Boolean. While we are here, I'd also like to add predicates for undo and redo. And that's just simply determined by the fact that undo redo lists have to have elements in them in order for us to have something to undo or redo. So if undo list doesn't have any items, that means that we can't press undo button to undo anything because there is nothing to undo. And the same holds for redo list or redo actions. I would also like to save the state of this build configuration in the project file. So the next time we open the project, this build configuration is automatically selected. Before testing this functionality to build the game code, we should remember to add 2 more configurations to our game engine solution as well, because remember that the game code links to the particular build configuration that we are using for the game code solution. So when we are building the game code DLL, it will look also in the engine output directory, which corresponds to the debug editor or release editor. But we don't have those yet, so I'm going to add those to our solution. Now, if we look at the properties in, for example, the engine project, we can see that everything has been copied from the release build configuration to release editor. So for example, the optimizations are turned on here, whereas the debug editor has optimizations turned off. The only difference that I want to have here is just to have a preprocessor definition that will let the code know that it's being compiled for the DLL. Okay, and while we are doing this, I just want to do one more thing. For the Primal editor, I just want to have this any CPU be for x64 platform. So I'm just going to add this new platform and copy the settings from any CPU, which is basically just a rename for this build configuration. And then we can just remove the old any CPU configuration. So now for any build configuration that we select, this platform x64 will be used for the editor as well. Okay. Now when I press F7 here, that's the hotkey for building the solution, it will just build the selected configuration for me. But I want to build everything for all configurations. And for that, I'm going to use the batch build. If you press Ctrl Q and search for batch build, you can see that we can build all configurations at once. So for example, for the engine project, I want to, of course, build everything, all configurations. For engine DLL, we only need the ones that are built for the editor. Obviously, engine DLL is only loaded in the level editor, and we don't need it for standalone game. Engine test doesn't really matter, so I'll just leave it like this. And Primal editor needs to be built for debug editor and release editor. So we can now clean our project. And again, I can look for batch build. But instead of searching for batch build all the time and doing it like this, I can just assign a hotkey to it. So again, Ctrl Q for searching for key bindings. And here I can search for batch build and assign a hotkey to it. For this, I'm going to use Ctrl Shift and F7. Now, whenever I press Ctrl Shift and F7, this window will appear and I can build my entire solution. Make sure to do this a couple of times because sometimes the dependencies aren't clear for Visual Studio, so it will use an older version of libraries and DLLs. So now I'm going to do it again. And as you can see, this time it's just one DLL that it made. So I think now we are ready to build the gamecode DLL. Now, because we added a new member to the project, namely that build configuration integer, we can't use the older projects anymore. So I'm going to create a new one. And right now we don't have any scripts in the project. So I'm going to add a couple. Here it is. You can see that script 01 CPP and script 01.h have been added to the project. And I'm going to add one more. This time, let's put it in another folder just to test that functionality as well. Okay, you can see the files here, but if you want to see the folder structure, you of course need to select show all files here, and you can see the folder and those two files in it. So we don't have any errors here, and then let's test if we can build the project if we press build. All right, as you can see, it built the project and it has one warning which says that this DT parameter hasn't been used, which is true because we are not using it here in update. But other than that, it works perfectly. We can choose release and build again. Here you can see that we built the project for debug editor configuration and it succeeded. And again for release build, and it also succeeded. I would like to actually separate these two tabs so I can see the undo redo history and the log messages at the same time. So now we can see the undo redo history and the log messages. And if I save the file, then we should see the save message. I think the save file message is underneath this bar, so I need to fix that. So here we need to tell this scroll viewer to start here at 32 pixels below because the height of our border is 32. So I need to put a margin here. Next, I'd like to actually go ahead and load the DLL that we just built. Here we can go to the documents, Primal projects, and see that we have the DLL here for our game code. And I would like to create a couple of functions in our engine DLL so we can load this DLL. Here in engine DLL, the C++ project that we have here, we have this engine API CPP. And it contains everything that has got to do with adding and removing entities. So I'm going to move this code to the file that I'm going to call entity API. And then I can use engine API to put other engine related functions in it. So let's copy this over. And because we also need this definition in Engine API, I'm going to move this to another header that I can include in both files. To load a DLL or a dynamic link library, we need to use a Win32 function. So therefore, I have to include the Windows header. And here we export two functions to load a DLL and to unload a DLL. This U32 integer is defined in Primal namespace, so I'm going to include a using namespace here. And of course, also the common headers from Primal Engine. This definition makes sure that some less frequently used headers from Windows header aren't included in the build. So that speeds up the compilation a bit. So to load the DLL, we should call load library. And we are going to use the ASCII version of it, because we have this array of characters here and not Unicode characters. So I'm going to just call it like this. And this gives us back a handle. It's an H module that we need to remember. So here in a private namespace or an anonymous namespace, I'm going to add a variable that I can use to contain that H module in. Before calling load library, we check script DLL to make sure that the game code wasn't already loaded. Or maybe just call it game code DLL to be more consistent. So this function will return false if gamecode DLL has already been loaded. And if that's not the case, we load the DLL, and if it succeeded, then we return true and false otherwise. Now to unload the DLL, it's again an API call to free library. Again, we check if this gamecode DLL is already loaded, which should be the case. So if it's not already loaded, then we return false. And this function will just return a Boolean. So we can just use this to return the result. So we free this library and then set this instance of HModule to a null pointer and then return true if everything goes well. And the next thing that we have to do is to import this in the level editor so we can use it in our code. So we open the engine API here. Here I'll put these methods that have to do with creating and removing entities in their own static class. And then here in Engine API class, I'll import the new functions that we just wrote to load and unload the DLL. And because this time we need to give the DLL name or path in ASCII format and not in Unicorn format, I'm going to let the marshaller know that we are using the ASCII and not the Unicode. I'm also going to rename this variable to engine DLL. And then going back to our project, we can implement these methods further to load and unload the gamecode DLL. Here first we need to determine where the DLL is located, and that we can figure out by looking at the configuration name. So this is the full path to the DLL that we just built for this particular configuration, whether it's debug editor or release editor. And then we can just check if it indeed exists. And then we can try and load it. So if we succeed loading this gamecode DLL, then we let the user know that that happened. And if we fail, then we also let the user know. But it's not an error, it's a warning, because even if we fail to load the DLL, we still can use the editor to put together the game world, right? And we do the same for unloading the gamecode DLL, but then we call the function and don't have to do anything else. And the last thing we need to do is to build our game code project whenever we load the project. So here on the serialize, I can call build game code. And I don't want to open the window, the Visual Studio window, whenever we just start the level editor. So I'm just going to pass false for show window here. So now we can go ahead and test if the loading and unloading of gamecode DLL works correctly. Because we moved these methods to Entity API, I need to also change this. I see I made a typo here. It should be game code, so I'm going to change that. This unload gamecode DLL doesn't need any parameters, so I need to remove these. Now, apparently, the editor can't find the engine DLL that we have, and that's probably because we need to set the proper path to those output directories. So here you can see that for debug editor, it's still looking in debug, and I need to change this as well. And now if I would run the editor, then hopefully it would find the engine DLL and import this function from that DLL. So as you can see here, it's saying that it built the game project for debug editor configuration successfully, and then it loaded the DLL. So let's say we do something. As you can see, this says that it failed. And that's because there is this PDB file. And because we loaded this DLL and unloaded it, Visual Studio somehow can't access this PDB file anymore. And we need to actually generate a different name every time we build the project. So here we can go to the project templates that we have. Here, for each of our configurations, we can set the program database file name. So as you might have guessed, I'm just using the normal target name and then append the time to the end of that file name. So therefore, each time we build this solution, we generate a new file name for that PDB file. Now, if you would create a new game project with the level editor and try to build multiple times, then it should work. Of course, we don't have anything to build yet for this new project. That's why it says failed to load the project. So let's create a couple of scripts again. And build. I think I made a typo here. Let's see what happened. I forgot this parentheses. There was a mismatch between parentheses, so probably it's going to be fine now. And let's go ahead and delete all these projects. Now every time we click on build to rebuild our project, a new PDB file with a different name will be generated. So if I change here something to make sure that Visual Studio will rebuild the project, then change it again. And now if we go to the build location of the game code DLL, we can see all those PDB files here being generated. And every time Visual Studio is going to refer to another PDB file. Now the problem is that if we are coding our game, then a lot of PDB files will be made. If we click on build multiple times, which we do, we'll end up with a lot of PDB files. So I'm going to put in Visual Studio class where we built the project a couple of lines of code to actually go and remove these PDB files before we start building. Now here, before starting to build the project, I can go through all the files in that directory where the DLL is located, and then just look if there are any PDB files in there and then delete them. Here we get a list of files, all the PDB files in this location. And then we call delete to delete the PDB file. But the problem here is that because we loaded the DLL, we could have a reference to one of these PDB files. And that would cause the delete method to fail and throw an exception, at which point we just skip this step by putting this in a try catch block. So that the next time that we build the project, when we have started the level editor again for the first time, then this will try to delete all the PDB files when we build the solution. So this way we kind of try to keep the output directory clean. The next thing that we notice is that whenever I try to open the level editor, when I click open, then you'll notice a long pause between this window going away and the main window appearing. And that's because in the background, Visual Studio is being loaded and this DLL unloaded and stuff happening. But in the meanwhile, the main window is just waiting on these steps to finish, right? And we can avoid this situation by making this happen on another thread. So I'm going to make build solution, or basically anything that has to do with building and running the game code asynchronous, so that we don't have to wait for it in the UI thread. Here in project, I'm going to make this method an asynchronous method. And when we call Visual Studio build solution, I'm just going to make this run on a different thread. Now in our code where we call build game code, we can just wait for it. But that means that we also need to make this undeserialized method asynchronous. And also here in this command, I'm going to put async and await. Now you see that this window opens immediately and then these messages appear. But now the problem is that we can't build our game anymore or use any of these buttons for that matter, like undo, redo don't work. And the only thing that works is new script. And that's because we are not using a command for this. We are just directly handling the click event in the code behind. So what's happening is that when we wait for this method to happen, the UI thread will continue and initialize the world editor. So if you can see here, we are binding to these commands. But that happens before we are done running this undeserialized method, which also includes initializing these commands. So what happens is that world editor is initialized and binds its commands to the uninitialized version of these commands, which is just nil, right? And when we set these commands, because we are not using onProperty changed on these properties, then the UI won't notice that we have set new commands, and then nothing happens. To fix this, we either can implement these properties as we do here by calling onProperty changed, but I can also put everything in one method because that way I don't have to change this to this. So what I'm going to do is just make a new method. And then I'm going to move this code where we set the commands to the new method. And then when we are done setting these commands, I call onProperty changed for each of these commands. This way now we can let the world editor or the UI know that we have set new commands and it should refresh its binding to these commands. can see that I can already use the UI and also save. So Control S executes that save command, and I can click on build and build the project. And like I did for the save command here in the world editor, I also want to add another key binding for building the game project. And I'm going to use the same hotkey as we use for Visual Studio, which is F7. And for redo command, I actually like Control-Shift-Z better than Control-Y. So when I am undoing or redoing stuff, I can just use the same fingers, basically. So here I'm going to change this to Control plus Shift. And when we are building the project, then because this build button is bound to the build command and it has got a predicate, it will be disabled. And we can also disable this new script button because while the project is building, we don't want to add new scripts. So I'm just going to use element binding and bind the isEnabled property of this button to the isEnabled property of the build button, which makes them both in sync. You can see that I'm able to use this box while it's also building the project. And the last thing that I'd like to do for today is to go ahead and correct a couple of typos that I've made in the last couple of videos. Here in new script dialog, I still need to add a private keyword here, just to be consistent with the other methods that I write. The default modifier for methods is of course private, but it's more consistent to just write it always. Next, here in main window, I'm initializing primal path to this hard-coded value, but that's not needed anymore because we have set the environment variable for Primal Engine location. So I'm going to remove this. And also I made a typo in engine path dialog when I'm typing unable to find the engine instead of enable to find the engine. And the next one is in controls number box. That's actually a bug because here, when we hold in shift, the multiplier changes to 0.1, but the default value should be 0.01. So the shift key makes the change of value faster and the control key makes the change in value slower. And the last one is in transform view, where I had this record action and I wanted to call it record actions. So I forgot an S. Let's close these files. So we added new functionality to Visual Studio class to build our code now. So we had methods to open Visual Studio, close Visual Studio, add files to the solution. And now we have a new method, and that's to build the solution. And we have a couple of other helper methods to let us know if the build is done or succeeded and those kind of things, or whether it's being run by Visual Studio. And further today, we wrote code to use this new build solution method in Visual Studio class in our project, and also wrote a couple of functions to load and unload the gamecode DLL. So when we are going to build the gamecode DLL, we unload the gamecode DLL, build it, and then reload it. And of course, right now, nothing really happens when we unload or reload our project because we are not doing anything with the game code in the level editor yet. So the next time I'm going to get the available script names and then use those to actually add scripts to the game entities. And then that way we can tell the project which entities have what behavior. So that's something that we need to do next time. And of course, we wrote a couple of functions to actually load the DLL in the C++ side. So now we import functions from Engine DLL that we can use to load the game code. So that's it for today. We now are in a position to actually prepare and run the game code. For now, thanks for watching. If you have any questions, we have a brand new Discord server. You can find the link in the description below. So feel free to join and ask me anything with regard to these projects, or just give feedback on the videos if you think something needs to be improved. I appreciate those a lot, and hopefully I'll see you next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!